Welcome back. In our previous lesson, we discovered one of the most important ideas in artificial intelligence. Instead of following thousands of manually written rules, machine learning systems learn by analyzing data, identifying patterns, and using those patterns to make predictions. But that naturally raises another question. Do all machine learning systems learn in the same way? The answer is no. Just as people learn in different ways, machines also use different learning approaches depending on the problem they are trying to solve. In today's lesson, we will explore the three main types of machine learning and understand when each one is used. By the end of this lesson, you will be able to recognize which learning approach is best suited for different real-world problems. Let's get started. Before we move forward, let's quickly revisit what we learned in the previous lesson. We discovered that machine learning is a branch of artificial intelligence that learns from data rather than relying entirely on predefined rules. Instead of telling the computer exactly what to do in every situation, we provide examples. The system analyzes those examples, identifies patterns, and builds a model that can make predictions or decisions when new data arrives. Now that we understand how machine learning learns, it is time to explore the different ways it can learn. Imagine teaching three different people to perform the same task. One learns by following a teacher's guidance, another learns by exploring and discovering patterns independently, a third learns through practice, making mistakes, and improving over time. People don't all learn the same way, and neither do machines. Some machine learning models are trained using examples where the correct answers are already known. Others discover hidden structures without any answers being provided. And some improve by interacting with their environment and learning from rewards and mistakes. Today, we will explore these three learning approaches and understand when each one is used. Today's lesson introduces one of the most important concepts in machine learning. You will learn that there isn't just one way to machines to learn. Instead, there are three major learning approaches, each designed to solve different types of problem. We will begin by understanding why different learning methods are needed. Then we will explore each approach one by one using simple explanations and practical examples. Finally, we will compare them side by side so you will know when each type is the right choice. By the end of this lesson, you will have a clear framework that will make many future machine learning topics much easier to understand. Although every machine learning system learns from data, not every learning problem looks the same. Imagine you are trying to solve different kinds of problems. Sometimes you already know the correct answers and want the computer to learn from them. Sometimes you have lots of data but no answers at all. You simply want to discover hidden patterns. And sometimes the computer must learn by interacting with its environment, improving its decisions through experience. These situations are very different. That's why machine learning isn't built around a single learning method. Instead, it offers different approaches, each designed for a different type of a problem. By choosing the right learning approach, we can build models that are more accurate, more efficient, and better suited to the task at hand. So, what determines which learning approach we should use? In most cases, it comes down to the kind of data we have. If our data already includes the correct answers, we can train the model by showing it examples of both the inputs and the expected outcomes. If the data has no predefined answers, The model must explore the information on its own and identify meaningful patterns or groups. In some situations, there isn't a fixed data set at all. Instead, the model learns by taking actions, receiving feedback, and gradually improving its decisions over time. So the learning method isn't chosen at random. It is driven by the nature of the problem and the information available. This idea forms the foundation of three main types of machine learning we will explore next. Let us pause and think about this for a moment. Imagine you are teaching someone a completely new skill. Which situation would be the easiest? If you already know the correct answers, teaching becomes much simpler because you can provide clear examples. If there are no answers, the learner has to discover patterns independently. And if feedback comes only after each attempt, learning becomes a process of trial and improvement. Machines face these same situations. That's exactly why machine learning has three different learning approaches. In the next section, we will begin with the most common and widely used approach, supervised learning. Before we continue, I hope you're finding this course helpful and enjoying the learning journey so far. If you're getting value from these lessons, I would really appreciate your support. Please consider liking the video, subscribing to the channel, and sharing your thoughts or questions in the comments. Your support helps us create more free, high-quality learning content for everyone. Thank you, and let's continue learning together. Let us begin with the most widely used type of machine learning, supervised learning. Think about how a teacher helps a student learn. The teacher doesn't simply ask questions. Instead, they first provide examples along with the correct answers. Over time, the student studies those examples, recognizes patterns, and eventually becomes confident enough to answer similar questions independently. Now look at the diagram on the screen. On the left, the teacher is showing the student different fruits, and each fruit is already identified correctly as an apple, banana, or orange. These are our training examples. In the middle, the machine learning model studies thousands or sometimes millions of these examples. It isn't memorizing every image. Instead, it learns the patterns that distinguish one fruit from another. For example, it may learn that apple usually have a certain shape, color, and texture, while bananas and oranges have their own unique characteristics. Finally, on the right, we give the model a fruit it hasn't seen before. Using the patterns it has already learned, it predicts that the fruit is an apple. That's the key idea behind supervised learning. The model learns from examples where the correct answers are already known and then applies that knowledge to make predictions on new data. The same learning process is used every day in applications like spam email detection, house price prediction, fraud detection in banking, and disease prediction in healthcare. In each of these cases, the model first learns from historical examples with the known outcomes before making predictions on new information. Now that we have seen how supervised learning works, let us explore some real-world business scenarios where this approach is commonly used. Not every prediction involves numbers. Sometimes we simply want the computer to decide which category something belongs to. This type of problem is called classification. For example, an email can be classified as spam or not spam. A bank transaction can be classified as fraudulent or legitimate. A fruit recognition system can identify whether an image contains an apple, a banana, or an orange. Notice that the answer is always one of several predefined categories. That is what makes it a classification problem. Now let's look at another kind of supervised learning problem. Instead of predicting a category, sometimes we need to predict a number. This is called regression. For example, instead of asking, is this house expensive? We ask, what is the estimated selling price? A retail company might predict next month's sales. A weather system might estimate tomorrow's temperature. The answers are numerical values rather than categories. That's the defining characteristic of regression problem. Let us look at a practical example. Suppose a real estate company has records of thousands of houses that have already been sold. For each house, they know details such as the size, the number of bedrooms, the location, and the final selling price. The computer studies these complicated examples to understand how different property characteristics influence the price. Once it has learned those relationships, it can estimate the price of a house it has never seen before. Notice something important here. The computer was able to learn because every historical example already included the correct outcome, the actual selling price. That's what makes this a perfect example of supervised learning. In supervised learning, the computer learned from examples where the correct answers were already known. But what happens if we don't have those answers? Can the computer still learn? The answer is yes. This is called unsupervised learning. Instead of being told the correct answer, the computer receives a collection of data and begins exploring it on its own. Its goal is not to predict a known outcome, but to discover hidden structures, patterns, or groups that humans may not have noticed. Think of it as exploring rather than being taught. The computer organizes the information by finding similarities and differences within the data itself. This makes unsupervised learning especially useful when we want to understand data rather than predict a specific answer. Let's look at a practical example. Imagine a retail company with thousands of customers. The company knows what each customer buys, how often they shop, how much they spend, and the type of products they prefer. However, it doesn't know how these customers should be grouped. Instead of manually analyzing thousands of records, the company uses unsupervised learning. The machine learning model examines the data and automatically identifies groups of customers with similar shopping behaviors. One group may consist of frequent buyers, another may include occasional shoppers, a third group might represent customers who primarily purchase premium products. These insights help business create targeted marketing campaigns, improve customer experiences, and make better business decisions. Notice that the computer wasn't given predefined groups. It discovered them on its own. Unsupervised learning is widely used whenever we want to discover patterns that are not immediately obvious. Retail companies group customers with similar buying habits. Streaming platforms can organize music or movies into categories based on viewing or listening behavior. News organizations automatically group similar articles together. Researchers use unsupervised learning to identify patterns in medical or scientific data. Retailers analyze products that customers frequently purchase together to improve store layout and product recommendations. The key idea is simple. Unlike supervised learning, the goal isn't to predict a known answer. Instead, it is to explore the data and uncover valuable insights hidden within it. Let us explore the third major type of machine learning. Think back to when you learned something like riding a bicycle, playing a game, or driving a car. Nobody could teach you every possible situation. Instead, you learned by trying different actions. Some worked well, some did not. With every attempt, you became a little better. Reinforcement learning works in a very similar way. Instead of learning from examples or discovering patterns in existing data, the machine interacts with its environment. Every decision receives feedback, Good decisions earn a reward. Poor decisions may receive a penalty or simply no reward. Over time, the machine learns which actions lead to the best results and gradually improves its performance. Let us look at a real world example. Imagine a self-driving car. Every second, it must make hundreds of decisions. Should it slow down? Should it change lanes? Should it stop for pedestrian? Each decision produces a result. Safe decisions move the car closer to its goal. Unsafe decisions are undesirable and are discouraged during training. Over many training sessions, often in simulations before real-world deployment, the system learns which actions consistently produce better outcomes. This continuous cycle of acting, receiving feedback, and improving is what makes reinforcement learning so powerful for decision-making problems. Let us test what we have learned. Think about the four scenarios on the screen. Which one best represents reinforcement learning? A. Predicting house prices from historical sales. B. Grouping customers with similar shopping habits. C. Learning to play a video game by improving after every attempt. D. Filtering spam emails using historical examples. If you selected option C, you are correct. A game playing AI doesn't begin by knowing the perfect strategy. It improves by playing repeatedly, making decisions, receiving feedback, and gradually discovering which actions lead to better outcomes. This learning through experience is what makes reinforcement learning different from the other two approaches we have explored today. Let us summarize everything we have learned today. Supervised learning is used when historical examples already include the correct outcomes. The model learns from those examples and predicts results for new data. Unsupervised learning is different. The model is not given the answers. Instead, it explores the data and discovers hidden patterns or groups. Reinforcement learning takes another approach. The model interacts with an environment, receives feedback, and gradually improves its decisions through experience. Although the learning process is different for each approach, the goal is always the same: help computers learn from experience and make better decisions. Let us check our understanding with three real-world examples. First, predicting the price of house based on historical sales. Since we already know the past selling prices, this is supervised learning. Next, grouping customers with similar shopping habits. There are no predefined groups, so the computer must discover them on its own. So that is unsupervised learning. Finally, imagine teaching a robot to walk. The robot improves by trying different movements, receiving feedback, and gradually becoming better. That is reinforcement learning. If you answered all three correctly, you have built a solid understanding of the three learning approaches. At the beginning of today's lesson, we asked an important question. Do all machine learning systems learn the same way? Now we know the answer. They don't. Some systems learn from examples where the correct answers are already known. Others explore data independently to uncover hidden patterns, and some improve through trial, feedback, and repeated experience. The key takeaway is that there isn't a single best learning method. The right choice always depends on the nature of the problem and the type of the data available. This understanding forms the foundation for everything we will learn next. We have now learned that machine learning systems can learn in different ways, but no matter which learning approach we choose, they all have one thing in common. They all depend on data. Without data, a machine learning model has nothing to learn from. That naturally leads us to our next question. What makes data so valuable, and why is it often called the fuel of machine learning? In the next lesson, we will explore the different types of data, understand why data quality matters, and build the foundation for concepts like data sets, features, and labels that we will use throughout the rest of this course. I'll see you in the next lesson, lesson 6. Thank you everyone. Have a great day ahead.